Welcome again in this lecture of the heat equation. Today I am going to solve those questions of the heat equation in which the ends of the bar are thermally insulated. That means the temperature gradient is 0. Should type 4. The ends of the bar are thermally insulated, that is, in this case your temperature gradient at x equal to 0, and when your length of the bar is L, in both cases our temperature gradient is 0. So let us solve a question. Find the solution of heat equation for the boundary conditions. The first is U is bounded for when t tends to infinity, and the second condition is that Ux naught is as t tends to infinity. Second condition is your temperature gradient is 0 for the both cases, and the third condition is your initial temperature Ux naught is L into x into L minus x into L minus x when your x is between 0 to L. So let us solve the heat equation with these boundary conditions. Solution of one-dimensional heat equation is A cos lambda x plus B sin lambda x into e power minus k lambda square t. Here we have to differentiate this equation with respect to x because the conditions are given for the temperature gradient. So del upon del x is equal to minus a lambda sin lambda x plus b lambda cos lambda x into e power minus k lambda square t. Now given that your del upon del x at x equal to 0 is 0. So when your x is 0, then we will get d lambda into e power minus k lambda square t, and from here you consider your b is 0. Again, your del upon del x at x equal to L is 0. So when your x is L, b is already 0. So we will have minus a lambda sin lambda L into e power minus k lambda square t. So again, as in previous cases, our lambda is n pi upon L. So using these two boundary condition, our b is 0 and lambda is n pi upon L. So b is 0. So you consider your solution is a cos lambda x into this term. Therefore, hence our solution is b is already 0. So our solution will be b is already 0, so our solution will be a cos lambda x into e power minus k lambda square t, and the general solution will be, and you can say, hence you can write it as hence ux equal to this one, hence your general solution is ux equal to summation say an cos lambda x. Now let us use the third boundary condition also. Your ux naught is equal to x into L minus x. So from here, if your t is 0, your left hand side will be x into L minus x, and in the right hand side we will have n equal to 0 to infinity an Now if your t is 0, then this will be e to the power 0 and e to the power 0 is 1. So we will have an cos lambda x. Now if you put n equal to 0, then in the right hand side we will have a naught plus n equal to 1 to infinity an cos lambda x. Let us choose this an as capital An. So your an cos lambda x. So your x into L minus x equal to an, this will be your a naught, plus n equal to 1 to infinity an cos lambda x. Now here you can see that your right hand side is half range cosine series because there is no term of sine. So in the right hand side we have half range cosine series, and for half range cosine series, for the half range cosine series, for half range cosine series, our a naught is equal to small a naught by 2, where small a naught is equal to 2 upon n 0 to l fx dx. Fx means your left hand side, and that means it is equal to 2 upon l 0 to l. Fx is x into l minus x into dx. So now you can integrate this one. So x integration of x will be x square by 2 into l, and then integration of x square will be x cube upon 3 in the limits from 0 to 3. So here you can see that your upper limit will be L cube upon 2 minus L cube upon 3. So this is your L cube upon 6. So that means this will be your L square by 3. Here we will have 6 and this 2 will give you 3. So L square upon 3. So this is your small a naught. Therefore your capital A naught equal to a naught upon 2. So this is your L square by 6. So we have the value of capital A naught. So this is your first term. Now let us find out an. An is 2 upon n 0 to l fx into cos n pi x upon l into dx. So this is equal to 2 upon l 0 to l. This was your x into l minus x into cos n pi x upon l dx. So on integration, the first term will give you lx minus x square into cos, integration of cos will be sin n pi x upon l into l upon n pi, then the limits from 0 to l, then we will have minus n, and differences from this will be your l minus 2x, and integration of this one will be cos n pi x upon l into l square n square pi square. Then we will have the third term, that is plus, and then the differences from this will give you minus 2, and integration of cos will be sin n pi x upon l into l cube upon n cube pi cube, and the limits from 0 to l. Okay. Integration of cos will be your sin, and then integration of sin will be minus cos, and integration of cos will be sin. Now here you can see that your upper limit for this term and lower limit for this term is 0. This term will get vanished for the both limits. Now only this term will exist for both the limits. So therefore our an is equal to, now this minus and this minus will become plus, so we will have 2 upon l. Now for the upper limit, our x is l, so we will have, and again this l square upon n square pi square is common. So for the upper limit, we have x equal to l, so this will be a minus l. And now if x is l, this will be a cos n pi is minus 1 for n. Now if your x is 0, for the lower limit, if your x is 0, we will have minus sign, so minus n, and cos 0 is 1, so we will have 1. So now, okay, now here you can see that we will have a common l common in the outside, so we will have l cube, so this will be your 2 l square n square pi square, then in the bracket we have one more minus sign here, so in the bracket we will have minus 1 for n plus 1. Now here you consider if your n is odd, then this is your 0, and if n is, let me cross check this answer, here your n is equal to minus, okay, this is correct. So now if your n is odd, then this will be your 0. Now if n is even, then this will be 2 times. So this is your 2 times if n is even, and it will be 0 if n is odd. Hence our solution is, therefore our solution was uxt equal to n equal to 0 to infinity an cos lambda x into e power minus k lambda square t. This was our solution, and if we break it into parts, then this will be your a naught if n is 0, and then cos lambda x into e power minus k lambda square t. So we can write it as a naught cos lambda x if your n is 0 into e power, lambda was n pi upon l, so lambda was your n pi upon l. So if n is 0, then your cos 0 is 1, so this will be your a naught, and again lambda was your n pi upon l, so this will be e power 0, that is 1, and then we have n equal to 1 to infinity an cos lambda was n pi upon l, then e power minus k n square pi square t upon l square. Now let us put the value of coefficients. So our a naught was l square by 6. Then now here I am writing n as even, and the value of an is minus 4 l square pi square cos n pi x upon l into e power minus k n square pi square t upon l square. So this is your answer for this problem. Ux equal to l square by 6, then summation when n is even, and this is your coefficient, and then cos n by x upon l into e power minus k lambda square into t. Now let us solve one more question. A bar 10 cm long, question is, a bar 100 cm long has ends at temperature with insulated sides, has ends at temperature 0 degree centigrade and 100 degree centigrade until the steady state condition prevails. Now the ends are insulated hence, so find the subsequent temperature at some time t greater than 0. Now initially the length of the bar is 100 centimeter and the temperature of the ends is 0 degree centigrade and 100 degree centigrade until the steady state condition prevails. And suddenly you can see that the ends are insulated, so you have to find out the uxt. So solution, in steady state condition, our uxt will be theta 2 minus theta 1 upon L into x plus theta 1. So here you can see that theta 2 is 100 degree centigrade, theta 1 is 0, length of the bar is 100 into x plus theta 1 was 0. So this will be x. So in this case our initial temperature is 0. So initial temperature is x. And now this problem is similar to the previous problem. Hence boundary conditions are, now your boundary condition will be, the first condition will be your temperature gradient at x equal to 0, and when your x is 100, at both ends your temperature gradient is 0, and then your initial temperature is x. In your last problem, this initial temperature was your x into L minus x. Now this is similar to the previous question. So let us solve this problem with the help of this condition. As in previous question, as in our previous problem, our uxt will be a naught plus n equal to 1 to infinity an cos lambda x into e power minus k lambda square t, and where your lambda will be n pi upon l. This was your solution in the previous question with the help of these two boundary conditions. Here you can see that if your temperature is 0, then your ux naught is this x. So if t ux naught equal to x, then your left hand side will be x, and in the right hand side we will have a naught plus n equal to 1 to infinity. Now if your t is 0, then we will have an cos lambda x, and lambda is n pi x1 l. Now here you can see that the right hand side is again half range cosine series, and for the half range cosine series your a naught will be, from here your a naught will be a naught by 2, and a naught is 2 upon n 0 to n fx dx, and your length of the bar is 100, so this will be 0 to 100 x dx, and integration of x will be x square by 2, so x square by 2, that means 100 square by 2, so this will be your 100 into 100 divided by 2. So here you can say that this is your 2, this is your 2, so this is equal to 100. So your a naught is 100, therefore your capital A naught will be a naught by 2, so this will be your 50. So your capital A naught is 50. Then let us compute your an. An will be 2 upon n 0 to n fx cos n pi exponent dx. So this will be a 2 upon 100 0 to 100, fx was your x. So 1 upon 50, then let us integrate this term, x into integration of cos will be sine, and then we will have minus sine, and integration of sine will be minus cos. Again here we will have n pi upon 100 upon n pi, then minus differentiation of x will be 1, and the integration of sine will be minus cos. And the limits will be from 0 to 100. Here you can see that your upper limit and lower limit both are 0. So this term will be 0, and this term will give you the values for the both cases. Now this is your minus minus plus, so this will be 1 upon 50, 100 square upon n square pi square, and here this is your, if your x is 100, then this will be cos n pi is minus 1 upon n minus 1. So therefore our capital A naught is, this will be your 100 into 100, so this will be 200 upon n square pi square minus 1 upon n minus 1. So this is our A naught, and hence solution is, therefore solution is uxt equal to A naught, I think A naught was 50, then n equal to 1 to infinity, this was your n square pi square minus 1 to power n minus 1 into cos n pi x upon 100 into e to power minus k n square pi square upon 100 square into t. So this is your answer. So this is the answer of this problem. Thank you so much for listening this lecture. Now, if you have any questions related to the heat equation and wave equation, then please mention in the comment box. I will try to solve.